All right, so we're going to go into Chapter 5, Lesson 2, and I thought we'd start off with a pretty cool experiment by Steve Spangler on The Ellen Show. You're going to see that they have some liquid in a graduated cylinder, and that liquid that they have in each one of those is hydrogen peroxide, comes in a little brown bottle, some regular dish soap, and they have this catalyst that we might take a look at in class. And let's just see what happens when they mix those together to get a reaction. So they're adding different elements together, different molecules together like we've been looking at. Let's take a look. All right, they call that elephant toothpaste. And if you're lucky, I think we'll probably do something with elephant toothpaste next week. So as long as we're working hard, we might get to make a couple of colors of elephant toothpaste. So we're going to go into Chapter 5, Lesson 2, Forming Solids. So that's our notes. And then we have our notes sheet here, Chapter 5, Lesson 2. Starts with metals, okay? So make sure we have all that together. Then move into our first slide. So we're going to be looking at some stuff building upon Chapter 5, Lesson 1, which is kind of just introducing to you the different types of bonds that we have and different things. And this is going to go a little more in depth into metals and metallic bonding. We talked about ionic and covalent bonding, but metals are their own kind of animal. So we're going to talk about those. So metals are elements that are usually shiny, good conductors of heat and electricity, and are solids at room temperature. And I think that we can all kind of grasp this concept of what a metal is. If you reach out to grab anything, like a fork or a spoon or nails or anything like that, those are all usually made out of metal. And we have some examples of common metals are gold, copper, aluminum, zinc, and iron. And on here you have a couple of those, a few of those examples. You have copper, there's some cast iron here, aluminum, and those are all, the aluminum and the copper are pure metals, and then cast iron, brass, they're all alloys, so mixes of a couple different metals. So the bonds that hold metals together are called metallic bonds, and a metallic bond is a bond formed when a whole bunch of metal atoms share their electrons. So in ionic bonding, you had one positive ion and one negative ion come together, and they bond together. Covalent bonding, you have the atoms sharing the electrons. In metallic bonding, the bond is formed by these metal atoms, okay, sharing the electrons. In this case are these little purple dots. They just share the electrons, and the electrons are able to move freely. They're not locked between these two metal atoms. They're able to flow freely throughout the entire substance. And in your notes, at least on this explanation point, I put a sea of electrons. So the electrons just kind of flow. And that free movement helps metals to be really good conductors of heat and electricity. Because the electrons are able to flow throughout the substance, and that free movement allows the conduction of heat and electricity throughout the entire substance very easily. Okay, so a metallic bond is different than ionic or covalent in that the electrons move freely throughout the substance. Okay, malleability, a tough word to say, but it is basically means that metals is the ability of a material, or in this case metals, to be hammered or rolled into sheets. So if something's malleable or has the property of malleability, it means that you can roll it flat or hammer it flat. And some examples I gave here are the metal on the outside of your car. That's a thin, flat metal that is then formed for your car. The skin of an airplane is made of aluminum that's light and durable, but is able to be flattened out. Or in this picture, you have what is called gold leaf. It's usually used to decorate things, and it's a very, very, very thin sheet of gold that's been hammered out. The next one is ductility. So ductility is the ability of a substance to be pulled into wires. So metals like copper, like you see here in this picture, okay, this is a copper wire, is very ductile, or has the characteristic of ductility, which means that metal is really easy to pull into a wire. And the example I give is a copper wire in your house gives you the ability to have light, power, and heat because it's able to conduct electricity through these thin wires. And as we're going through, I hope make sure that you guys are going and drawing your pictures from the metallic bonds slide. You should have drawn an example like this, metallic bond, the positive nuclei with all the electrons all over. And then there aren't any other drawings to do as yet. So, okay. So we were on ductility, so ability to be pulled into wires. Now we're getting into crystals. So we're moving away from metals and going into crystals. And a crystal is a regular repeating arrangement of atoms, ions, or molecules. So basically, we all kind of know, or what we might think of as a crystal is this picture here, just a chunk of shiny, clear, sparkly rock. But a crystal can be either atoms, ions, or molecules. So we've got a couple of different examples here. A molecular crystal is something like a snowflake. So a snowflake is a regular repeating pattern of frozen water molecules. So molecular crystal, snowflake, is a repeated pattern of water molecules. An ionic crystal would be something like NaCl or table salt, sodium chloride. So you have the positive sodium ion, the negative chloride ion that come together to make table salt. So table salt is a common ionic crystal that you would see in your day-to-day life probably. And then an example of a covalent crystal would be something like a diamond. It's a regular repeating pattern of covalent bonded carbons, and they're super pressurized and heated, and that's a diamond. Okay, so in your notes, I want you to draw an example of a crystal, and what I want you to draw is something that looks like this. Don't draw the big chunk of rock. I want you to draw one of these kind of more structurally drawn examples. You can just draw this easy one right here. So this is giving you an example of a cubic crystal unit. And you can just draw the circles and the lines in between, because basically this would be one unit cell of a crystal. So the unit cell is the smallest repeating pattern that shows how atoms, ions, or molecules are arranged in a crystal. So one single crystal in the entirety of the big crystal. Okay, so again, here's this picture of one unit cell. So the crystal itself is probably a giant chunk that looks like a big square. So if you're thinking of the rock form of a big square crystal or a big rectangular crystal, but it's made up of billions or however many of these small repeating units of the same shape, they're just extremely small. So unit cell, smallest repeating pattern that shows you how atoms, ions, or molecules are arranged. So this would be how they're arranged. A polymer, so now we're on to polymer. So I want you to draw this picture here, okay? You can just draw the monomers and the polymer in that box in your notes here in this box, okay? A polymer is a covalent compound that's made up of many small repeating units linked together in a chain, okay? Word polymer means many parts, so poly, many, mer, many parts. And polymers can be natural or synthetic. Examples of natural polymers could be cellulose, which is a polymer that makes up plants. Keratin, it's what's in your hair and nails. Those are natural polymers, or synthetic polymers are things like plastics, and those types of synthetic materials. And then lastly, you have a monomer. And a monomer is a small molecule that forms a link in a polymer chain. So here we have again the pictures. Monomers are these small molecules that when they're linked together like this form a polymer chain. So example, if a polymer is an entire necklace, if you wear a necklace that has links, then a monomer would be one single link on the necklace. So here you would have the whole necklace, and then this would be each individual link that makes up that necklace. Okay, and I put a star by the monomer of what that looks like, and here there's a star by the polymer. Okay, so make sure that you know the difference between those two. Polymer is the whole chain, monomer is the links that make up the chain. All right, well, you guys, I will see you tomorrow in class. Hopefully this was helpful, and we'll go over it tomorrow. Have a great one.